We are also concerned with other groups of elements, and I have some shown here on this periodic table. Fuels. Some elements are pretty good fuels. I've mentioned hydrogen previously. That's been used in a number of applications, although it's not economically feasible for everybody to use. It has some specialized applications. The now retired space shuttle went to the moon based on the reaction of hydrogen as a fuel reacting with oxygen as a propulsion system. Carbon, we dig up from the ground and burn enormous quantities of coal, largely because it's mainly carbon, and the carbon burning is what we use, and that's used generally to make electricity and then for some other industrial applications. Coinage metals. Traditionally, coins have been made of copper, silver, and gold. Gold's more precious, so we have the more precious coin, and certainly we have these silvery kind of pennies and quarters and things. Silver's gotten expensive enough, but pre-1959 quarters were made out of silver, so historically silver's been used for lots of coins, and certainly the copper. The reason for that is that these three metals and a few other ones are very inert. They don't react very much, so the coins will stick around for a very long time. Modern day coins have gotten a little bit more sophisticated. Zinc would be terrible as a coinage metal because it would corrode in the atmosphere. However, modern pennies are almost all zinc with just a coating of copper to protect the zinc. So these days coinage metals have changed around a little bit. Canadian money has a lot of nickel in it. Nickel's pretty good, but it's too expensive for us, but not so for Canada. But these three are what I will call coinage metals. In addition, lighter than air, we see a lot of gases that can be used to float balloons and even float flying machines. There used to be blimps that were much more prevalent than they are these days, and they're used with gases that'll float. We also need to be aware of gases that'll float because if they have some sort of reactivity, the reaction's going to happen in the ceiling rather than happen on the floor if these gases are to float. I've got the example of helium. We put that in party balloons, and of course my helium tank here, if I turn it on and I get my bubble generator going, we can certainly see that helium allows the bubble to float. One that's not as commonly known but is worthwhile knowing is hydrogen. This one floats as well. It has a long history of being not as safe as helium, but it can be put into balloons, it can be put into flying ships. I just have to get my hydrogen generator going here. Okay, so there's my hydrogen generator, and we should be able to get a bubble of hydrogen going, and hopefully this will float as well, so that I know what I'm talking about. It's not coming out quite as fast. Whoops, we missed it. If it doesn't come out fast enough, sometimes these bubbles don't work so well. I'll try to get it to come out a little faster. It's trying. Oh, it popped. Hold on. we've got our hydrogen bubble generator going, and hopefully we can make a hydrogen bubble and show that hydrogen is in fact lighter than air. There, the bubble goes up. Now the other thing to be careful about with these gases is their reactivity. Helium's quite unreactive, but we've got sort of a different situation with hydrogen, and we can see that very easily if I set up a sort of a burning splint kind of thing here and ask the question, what's going to happen if the hydrogen bubble hits fire? Whoops. It's hard to say because I missed. You may have heard that more than seen it. Hydrogen's terribly flammable. So it's worthwhile knowing when hydrogen is released, because it's going to go up and it's going to be flammable. And